Hi, hopefully you're here fresh from viewing the video of the activity in the chips. And if you haven't watched the video, I'd recommend that you do so and come back to this lecture later. The power of a good simulation lies in creating a common experience, and we use that common experience as the basis for teaching. We should never fool ourselves into thinking that the simulation actually does the teaching. That's our job. The In the Chips activity lets students experience a market in a simplified setting that makes it easy to point out the mechanics during the debriefing. Also, and I can't overstate the importance of this factor, this activity is so transparent that students know that they're not being manipulated. What happened, happened, and it was the result of their freely made choices. The prices emerged from their interactions and were clearly not orchestrated or predetermined. At the end of the last lesson, I argued that price changes are powerful incentives because they change opportunity costs. In debriefing in the chips, you can reinforce that relationship between prices and opportunity costs. Here are the pertinent questions. First, which is it better to have, a high buyer card or a low buyer card, and why? Now, what you're really asking your students is, what does a high buyer card or a low buyer card signify about the buyer? Now, students will readily express their preference for the high buyer card, and they generally leap to the conclusion that the buyer with the high card is rich and the buyer with the low card is poor. Okay, that works. It translates well into opportunity cost. For a rich buyer, the opportunity cost of spending $1 on computer chips is low. If you have lots of dollars, the opportunity cost of spending any $1 on anything is probably pretty low. And the opposite's true. If you don't have a lot of dollars, and dollars are hard to come by, then the opportunity cost of spending any dollar on anything is relatively high. But there's another explanation, and this is the point that students will have jumped past. It's equally plausible that the buyer places so much value on the computer chips that she's willing to pay a high price even if she's poor and is bearing a high opportunity cost. Aha! Now, can you think of a real-world scenario in which that's the case? Suppose someone's starting a new business that depends on his computer working, or a student is studying overseas and has no phone, uses her computer to keep in touch with her family and boyfriend back home. There are lots of examples, because in real life, it isn't just a case of poor people only buying cheap things and rich people only buying expensive ones. What matters in each decision is the opportunity cost. Okay, so students tend to readily accept the connection between opportunity cost and consumers' purchasing decisions, but they generally haven't been producers, so that connection is harder for them to make. Start by asking again, which is it better to have, a high seller card or a low seller card, and why? Remember that what you're really asking is, what does a high seller card or a low seller card signify about the seller? They know from their experience in the game that it's definitely better to have the low seller card, but they're unlikely to have thought through what that means. If you ask, they usually come up with efficiency. That is, that the low seller card means a lower cost. They may say that the person is a better producer. And conversely, a high seller card means a high cost, or in their terms, a not so good producer. The explanation that sellers have different resource costs, production costs, is certainly correct, as is the insight that some sellers do a better job of keeping their costs low than others do. But as with the consumer cards, there's another possibility based on opportunity cost. Suppose that the high seller card actually represents a producer with very low production costs, except for one, the opportunity cost of his time. I usually choose some poor unsuspecting kid and tell the rest of the class that in addition to making computer chips, he's in a boy band and he makes big bucks giving concerts to screaming, crying 12-year-old girls who buy his recordings by the millions. So the opportunity cost of making computer chips, which, by the way, his company is very good at, is that he'd have less time to tour with his band. Therefore, he's only willing to put time into running the computer chip business if he can charge a high price. They usually get the point. Okay, next question. What was the equilibrium price and where did it come from in our game? Don't skip this question because the answer seems obvious. It is, or it will be after the experience, but the value of articulating the obvious is high here, and you're going to want to refer back to this again and again during the course. The equilibrium price, which is actually probably a small range of prices in your game, came from the interactions of the buyers and sellers in the market. It happened all on its own, wasn't set or predetermined. You're going to have to fight this preconception all semester that businesses set or control prices. And the activity experience is going to be an important counter for you to keep pointing back to. So, ask the sellers, could they set the prices? They'll quickly tell you that they could put out any price they wanted to, but that didn't mean the buyers would buy. So, this is a good time to introduce the distinction between a price tag and a market price. Yeah, sellers can put any price on the tag that they want to, but they can't make consumers buy. Price, or market price, if you will, is that price at which the transactions actually take place, and it's the result of the interactions of buyers and sellers. That interaction is unscripted and probably was pretty noisy in the case of your game, and it's usually referred to as competition. And again, you can use this opportunity to dispel the mistaken belief that's seldom stated but widely held. Ask your students, were you in competition in this activity? And if so, who were you competing with? As they think about it, they'll realize that buyers and sellers are not competing with each other, which is the way we tend to kind of portray it in everyday conversation. Instead, sellers are competing with other sellers, and buyers are competing with other buyers. How did they compete? Sellers competed by being willing to sell at a lower price than other sellers. Buyers competed by being willing to pay a higher price than other buyers. Next question. Who won the competition? The buyer and seller who successfully completed a transaction both won. In a very real sense, their relationship was cooperative rather than adversarial. When they made a transaction, they both successfully competed against all the other buyers and all the other sellers who were looking to make a similar exchange. This win-win nature of market competition is an extremely important characteristic, and we'll look at it more in depth later on. So, why did we play first? Well, it's about creating the experience. The simulation sets the stage for the teaching. Then, in the debriefing, students are helped to articulate what they experienced and to analyze the results using the economic reasoning tools they're working on. That's the teaching, the consciously connecting the experience to the reasoning. By running in the chips, you let students experience an institution, a market with a set of rules of the game, both formal and informal. And we know some things about institutions from our earlier lessons. First, they're the informal and formal rules of the game that shape incentives and outline expected and acceptable forms of behavior in social situations. Institutions set up incentives, rewards, and punishments that encourage or discourage actions. And furthermore, when incentives change, people's behavior changes in predictable ways. In the chips and in our economy in general, the institution we've adopted to deal with scarcity is markets. And the incentive that shapes people's behavior in those institutions is price. We argued in Lesson 1 that a nation's choices of institutions matter. We asserted that markets, property rights, and entrepreneurship are key institutions for promoting economic growth and raising standards of living. So, as we go forward to connect the simulation to our previous learning, the next step is to look more carefully at the institution itself, at the rules of the game that guided the students' interactions in the activity. The economic model that outlines the institutional rules of the game in markets is generally referred to as supply and demand. In the remainder of this lecture and in the next one, we'll look at the components of that model: demand, supply, and equilibrium price. In the assignments for these lessons, you'll practice using the model to analyze real-world scenarios. So let's get started. First, what's a market? Not a difficult question, but worth just a little bit of time, if for no other reason than to awaken us to the ubiquity of markets and their ability to overcome barriers, even it seems barriers of time and space. A market is simply any place where buyers and sellers interact to exchange goods, services, and resources. We've gone far beyond the day when a market only meant farmers with stalls selling fruits and vegetables, so we need to define any place as broadly as possible. eBay's a market, right? And where exactly is it? And when is it open? On the screen is the URL for a great little video on YouTube. It's Weird Al Yankovic singing about eBay. And given that it's on YouTube, it may disappear, so I haven't put an active link in this video, but you can copy down the URL and try it on your browser. The students in our summer programs liked it enough to sing along, even if I was the only one old enough to remember the Backstreet Boys. But it definitely makes the point that markets aren't just places, they're a way of interacting. Markets exist wherever and however buyers and sellers interact, and technology is spreading that ability to interact. Think of the advantage to this village farmer in India who can check market prices or find a buyer before harvesting his crops, or to the Maasai herdsman deciding whether to sell or buy more cattle. Okay, so brief review. The institution is markets and the incentive is price. And one of the things we know about incentives is that people react to incentives in predictable ways. So what the model of this market institution should be able to tell us is how people react to changes in that price incentive. In other words, the model should help us to understand how price affects the amount that is bought and sold in a market. The rules of the game for market institutions specify that there are two types of players: buyers and sellers, or as our model calls them, demanders and suppliers. We'll start with the demanders, the consumers. The most important feature of demand is that it isn't just want or like to have. Demand doesn't exist unless there is also willingness and ability to pay. Can you see where the price incentive is going to come in here? Lots of people want beach vacations and snazzy cars, but without the willingness and ability to pay, there's no demand. Conversely, ability to pay isn't enough to create demand on its own. Lots of people are easily able to pay the 10 cents a cup, but as budding lemonade stand entrepreneurs often discover, there isn't a lot of desire for their product. Willingness and ability to pay. In other words, price matters. It is the most powerful and predictable incentive shaping the choices of buyers and sellers in markets. And if you'll recall our economic reasoning proposition, changes in incentives cause predictable changes in people's behavior. So let's see how that works on the demand side to shape the behavior of consumers. An analogy I find to work really well in explaining how price and demand are related is that of a snapshot. Click, a single digital click that freezes the action at a specific point in time. Use it to simulate a demand schedule. So take any three students, with their particular circumstances, incomes, tastes, and preferences, right here, right now. Click, freeze the action. Okay, Eli, given your current income and tastes, and assuming that there are lots of movies out there that you'd like to see, how many movies would you go to see each month if the theater ticket price were $2, $5, $8, $15? Okay, so what we see in column 1 tells us how Eli's behavior changes with the changing incentive of price. Okay, student 2, Keisha, same question. Here are the numbers, or economists call it QD, or quantity demanded. of movie tickets that Keisha would buy at this particular moment in time under her particular circumstances at various ticket prices. Third student, Lee, same question. Different answers. Maybe Lee has a good job or a big allowance, or maybe he just likes to go to the movies more than anyone else. We don't know why each student has these numbers, and as we'll discover, the market doesn't need to know. In any case, what we have here is a picture. It's in table form, but it shows us how Eli, Keisha, and Lee's behaviors react to changes in what? Right. Their behaviors react to changes in price. Price is the incentive that causes the differences we see here. Because remember, we set it up that way. We froze the action, click, at this moment with these conditions. The only thing we allowed to change was the price. And the table shows us a relationship between the price of movies and the number each student would purchase, the quantity demanded, as an economist would say. And note that that's all this table is telling us. So it might be helpful to remember to think of this relationship as the price effect. Now, what do you notice about the price effect? That is, the relationship between price and quantity demanded for each of the demanders, Eli, Keisha, and Lee. Hopefully, you notice that even though the quantities are different, there is a similar trend. When the price goes up, the demander purchases less, and when the price goes down, the demander purchases more. That's the effect of changing the incentive that buyers face, the price. It is such a predictable effect, such a predictable reaction, that economists call it a law, the law of demand. Now, there are lots of ways to picture the law of demand, and I'm going to have to go a little off track here to jump on my soapbox about graphs. Don't get me wrong, I am a graph person. Graphs turn on light bulbs in my head, but somewhere along my teaching career, I realized that not only is that not true for everyone, it may not be true for most people. How about that? Am I actually suggesting that being able to graph supply and demand isn't the be-all and end-all of learning economics? Well, yes, I am. And I'm belligerently unrepentant about making that recommendation. I just showed you a table picture of the relationship between price and quantity demanded. It worked. And you could write a story picture or you could make a movie picture. As long as they clearly show the relationship between price and people's willingness to buy, they work. And yes, the conventional picture of the law of demand is a graph. And if you're going to be an economist, you've got to be able to graph. Yeah, I know. And if you're going to pass the AP or IB test, you also got to be able to graph. But I think it's really important here to not confuse the ability to graph with understanding how markets work. I had lots of students who struggled with graphs but could still provide me a perfectly coherent picture of the law of demand. Think about that when you're teaching that diverse population of kids sitting in front of you. Do you want them to be able to draw a graph, or is your goal that they understand how consumers react to changing prices? I know. The answer is both. But if the alternative is neither because they hyperventilate when you pull out the graphs, you might want to accept what one of my profs used to call telling a plausible story as sufficient for a passing grade. Okay, end of soapbox diversion. So, this is the conventional picture of demand, a snapshot that would emerge from the click of your economic camera. Note the axes, quantity on the horizontal, price on the vertical. Remember that we're picturing the relationship between price and the quantity that people buy. Now, be ready for your advanced science students to tell you that this graph is backwards. Don't argue, they're right. The dependent variable, which is quantity, because the quantity people buy depends on the price, is on the horizontal axis instead of on the vertical one, as is conventional in science and math. There's some long involved explanation for why that's the case, something to do with a long-dead economist named Alfred Marshall, who looks like he'd be mad if you told him it was backwards, But the technical explanation you want to give your students is, and read my lips carefully here, because that's the way economists do it. Okay, a little graph review is useful. Note the direction of increase. Prices rise as we go up the vertical scale. Quantity rises as we go to the right. Remember that the intersection of the two axes is assumed to be 0. Pay attention to the fact that each axis should be marked in uniform units, starting from 0. Okay, armed with our basic graphing skills and the table, ta-da! Here's a picture of Eli's demand for movies at the time the camera clicked. How do I know that's the picture? Well, let's check. Choose a point, any point. Draw a dotted line over to the price axis and one down to the quantity axis. Check the other picture, the table. Isn't that what Eli told us, that at a price of $8, he'd go to 4 movies? So this is just a picture of Eli's demand, and it's similar to the graph. We can also put other people's pictures on the graph, or we could add up everyone's responses to our question of how many tickets they'd buy at different prices and create a picture for the whole class. So let's add some more demand pictures. Okay, now what do you notice about these pictures, or demand curves as they're properly called? Yes, they all slope downward to the right. So go back to the table. What did you notice? At higher prices, the quantities purchased were lower, and at lower prices, the quantities purchased were higher. That fits with the lines on the graph, doesn't it? Well, let's look. Here's our graph picture. Okay, pick another point, any point. Draw the dotted lines and compare the prices and quantities at the 2 points. Does this picture show the same relationship as we saw on the table? Yep, exactly. Higher prices, lower quantities. Points in the upper left where prices are high and quantities are low. And lower prices, higher quantities. Points on the lower right where prices are low and quantities are high. This is the law of demand. And remember that what it tells us is the price effect on buyers. If price rises, quantity demanded falls, and if price falls, quantity demanded rises. Nothing changes except the price. Okay, you're a buyer, we're all buyers. We've been demanders since we were born. So we intuitively believe the law of demand. But think about why and how it works. It works because there are substitutes for everything. Really, everything. Substitutes, substitutes, substitutes everywhere. Now, I'm not suggesting that there are always good substitutes, just that there are substitutes, even for things we tend to regard as necessities. For example, what about gasoline? Here's a whole range of gasoline substitutes. Some of them are much easier to accept than others, and some are much easier to accept for some people than for other people. What the law of demand is telling us is that as the price changes, we'll be more and more willing to make substitutions. And if the price goes high enough, we'll even make difficult choices that we wouldn't have believed possible if someone had asked us when the price was low. And don't forget your lesson about the margin. We tend to make substitutes at the margin, a little more, a little less. When the price of gas goes up, we aren't likely to immediately sell our cars and start walking. Instead, we'll pick one of the easier substitutions, like carpooling with a friend 1 or 2 days a week, or taking the express bus. And conversely, when the price goes down, we don't run out and buy a new gas guzzler, but we may drop the bus for the convenience of driving ourselves. Okay, so back to the picture of demand we created. We use the analogy of a snapshot, a frozen moment in time, to collect our data. The assumption, which is called ceteris paribus by economists, means everything else remains the same. It's like we asked Eli, Keisha, and Lee, if nothing else changed, how many movie tickets would you purchase if the price was X dollars per ticket, and we kept changing the X dollar price? If everything else remains the same. Okay. But what if it doesn't? Then what we have to do is take a new picture. Okay, here's Eli's new picture after he got an after-school job. Here's Keisha's new picture after her family got a big screen TV. Here's Lee's new picture when he quit his job so he could study more for his exams. Let's look at it on a graph. Here's Eli's new demand curve. What's the same? What's different? Well, to start with, both demand curves still slope downward to the right. That's a good thing because it means the law of demand is still in force. People buy more at higher prices and less at lower prices. But notice that Eli's demand curve is in a different place on the graph. Which way did it move on the quantity axis? Towards the bigger numbers, that is towards the right, or toward the smaller numbers, that is toward the zero on the left? Okay, movement to the right is an increase. Eli's demand increased at all prices. At all prices, he's willing to buy more because with his new job, he has more income. But no, Eli still hasn't escaped the law of demand. The quantity he purchases in this new set of conditions still is dependent upon the price. Even though he's willing to buy more at any price than he was before the new job, he's still not willing to buy as much at higher prices as he is at lower prices. That's the difference between talking about demand and quantity demanded. The non-price factors that sometimes change the whole demand picture, that are not the price effect, are sometimes referred to as demand shifters or the determinants of demand. They include, as you'll see from the list on the screen, changes in tastes and preferences, changes in the numbers of consumers, changes in the prices of substitutes for whatever product we're talking about, or changes in the price of complements, products that go together, and finally, changes in consumers' expectations of future prices and, importantly, as we saw with Eli, in their incomes. So with this list in mind, think back to Eli's pictures, the graph and the chart. From the information I've given you, which of the factors on this list shifted his demand for movies? Right, his income increased. And under those new conditions, click a new picture, he was willing to buy more at every price. So his total demand increased. Or, in graph speak, what we saw was that his demand curve shifted to the right. Okay, what about Keisha? Sounds like the price of substitutes has changed for Keisha when her family got a big screen TV. Now she can get a big screen movie experience without paying the price of a theater ticket. So the substitute, movies at home, is cheaper, and Keisha's demand for theater movies falls, moving her demand curve which way? Yes, to the left, toward the smaller quantities of theater tickets. Okay, you're getting pretty good at this, but what about Lee? Quit his job, studying more? Well, certainly his income has changed, but it may also be that his newfound desire to get into college so he can move out of the house has changed his tastes and preferences. In any case, his demand picture is different. His demand for movies falls, shifting his demand picture to the left. Okay, before we leave this graph, here's one last question. What if the price of movie tickets in Lee's town goes up? Now what happens to Lee's demand picture? Be careful now. Think this through. Time's up. Thanks for playing. The answer is nothing. Zip. Nada. No change. Lee's demand picture already tells us how many tickets he'd be willing to buy at different prices, and the price was the only thing that changed. The question that I asked you captured the price effect. So, as you analyze real-world problems, before you get carried away looking for demand shifters, the first question to ask yourself is whether the price of the product, in this case, the price of movie tickets, has changed. If you answer yes, then it's the price effect, and the law of demand will tell you what happens. Only if you answer no there's no price effect, do you start looking for demand shifters. Okay, enough talking. Time to practice some demand analysis, but don't forget that we've only looked at one of the players in the market. In the next lecture, we'll switch to the perspective of the seller and study the various pictures of supply. When we have both pieces in place, then we'll consider the dynamic equilibrium that emerges in open, competitive markets.